Today I'm going to be explaining how to solve the TwoSum problem on the Blind 75 list. For those of you who don't know, the Blind 75 is a list of questions curated by a LeetCoder who was hired by a FANG company and is considered to be a good starting point to get your feet wet in understanding how to solve most problems that you'll experience in a technical interview for big tech companies. This list will give you an idea of the most common types of problems you will see, as well as teach you the patterns that will help you solve similar problems. The key to solving the medium and hard problems is to understand the common algorithms and data structures used throughout the list, and then use the techniques in conjunction with each other to solve the harder problems. The TwoSum problem is an array question. Most array and string questions can be solved using a hash table, the sliding window, or the two-pointer approach. We are first going to check out the hash table solution, and then we will solve this same problem using the two-pointer approach. Keep in mind, the second approach only works if the array is sorted. If you want to see more videos like this, please take the time to subscribe now to see more of my future videos. Alright, so let's get started. So the description of the problem is: given an unsorted array of numbers and an integer target, return the indices of the two numbers such that they add up to the target number. We're also given that there is for sure a solution somewhere in the array, so we don't need to worry about any exceptions. We also can't use the same element twice, and we can return the index numbers in any order. An example of what we are looking for looks like this. So we have an input of nums, which is an array, and inside our array we have 2, 7, 11, and 15, and then we have a target equal to 9. Our output should look like this, with an array with a 0 and a 1, because 2 plus 7 equals 9. Alright, so let's take a look at this. We are given an array and a target, and our variables will be our hash table, called indices, and our current sum, so that we can keep track of our target when we reach it. So what we're going to do is we're going to loop through the array. So we'll create an I value right here to signify us looping through our array. And our current sum down here is going to start as our target number, which is 9, minus the first number in the array, which is 2. So 9 minus 2 is going to be 7. So the current sum right now is 7, which is also how much more we need to reach the target number. So first, we must check that if our first number, 2, which is where our I value is already in our indices table. But we just started, so we know it's not. Therefore, what we're going to do instead is we're going to put that number in our hash table with the key being the number 2. So we're going to go 2, and we're also going to put the index value 0 as its value. So 2 and 0. So our indices table currently looks like this. We then can move our index forward by 1. So if you remember from before, our current sum was 7, but we moved forward by 1. And now we will set the current sum using the next number in the sequence. So we will do the same thing as before and make our current sum equal to our target number, 9, minus the next number in the sequence, which is 9 minus 7 equal to 2. So the current sum is 2. We then will check to see if our current sum is a key in our indices table already. As you remember from before, we did save a 2 right here inside of our indices table already, and it has a value of 0 because that was its index in the array. So because we have a match right here, we are now going to return an array, and inside we will have our current index, which is in this case 1. So now because we have a match, we are going to return an array. And inside we'll have our current index, which in this case is 1. So right here, this is 1, because the index of number 7 is 1. And then we head over to our indices table, and our current sum is the key that we need to use to get the index value out. So the current sum right now is 2, and we're going to look to see if that matches any of the keys in our table. So we have right here a 2, so it does. And what we're going to do is we're going to return the value, which happens to be the index 0, as our second number in our array. So we're going to take that 1 right here, and then after we check, we get 0. So our output is an array with the index values of 1 and 0. We are then done and have solved the problem. This problem uses a loop, so our time is always going to be worst case O of n, and our space is also O of n, because worst case, we will insert n numbers into our hash table. Alright, so let's take this over to VS Code. So what we're going to do first is we're going to create the function, so TwoSum, and inside of it we're going to have our two variables, which is nums, which is our array, and then our target value. So what we're going to do first is we're going to just create the hash table indices. as a dictionary. And then what we're going to do is we're going to just loop through the array. So for I in range of nums. Next, we're going to save the current sum at target minus the number at the current index. So that was that current sum equal to the target minus nums I. So that's going to be that value, if you remember, the actual value, not the index value. So the value that currently is. So that's going to be our current sum at our index. So next we're going to check to see if the current sum is a key inside of our indices table. So if current sum in indices. So if it is, what we're going to do is we're going to return an array that has the index value we are at now and the value saved inside our indices table by matching the current sum to the key inside of the table. So we're going to just be returning an array that's going to have the index value that we're currently at, which is I. And we're going to take that indices value. So we're going to go over to our table and we're going to use our current sum key to unlock it and get the value out of that. So if there is not a key that matches the current sum, so we don't find anything inside of that indices table, this is going to be our else statement. What we're going to do is we're going to save the number at the current index as the key and set the value equal to our current index. So we're going to take that indices and then we're going to have nums at I, so the value that we currently have at our index, and then we're going to set that equal to I. And it is I because what we're doing is we're saving the value as the index. Even though we used the actual index value inside of it, we are saving the actual index as our value. So the first one, if you remember, it was 0. The next one, it was 1. So right now we're saving 0 for that 2 value. So we can just, I'm going to go right here and I'm going to grab some print statements that are going to have it. And then we're going to save that, go ahead and run it. And as you can see right here, we were able to get the values for all of them, just like that. So the next technique we're going to look at is the 2-pointer technique. How we're going to do this technique is we have the left pointer right here, which is going to be P1. And then we also have this right pointer, which is going to be at the end of the array, P2. So while the left and right pointer are not equal to each other, we can loop through this array. So just like before, we're also going to have a current sum variable, just to keep track of our current sum as we go along the array. And currently, that current sum is going to be equal to the values of P1 and P2. So the actual values, not the indexes, which in this case is going to be 2 plus 15, which is going to be equal to 17. We're then going to check to see if the current sum equals our target number. So does 17 equal 9? No, it doesn't. And that number is larger than our target number. So what we're going to do is we're going to decrement the left pointer P2, because since this list is sorted, if the number is greater than the target number, we're going to decrement instead of increment. So we're going to move backwards so that we can get a smaller number. And we're going to move our P2 over by 1. So P2 now equals 11. So we're going to do the same thing. So we're going to delete our current sum that we currently have, and we're going to add these together. So 11 plus 2 equals 13. So still what we see is that this current sum is larger than our target number. So 13 greater than 9. And as we know from before, that if the current sum is greater than our target number, we're going to have to decrement the pointer too. So we're going to do the same thing as before. And I'm just going to also delete that current sum. And we're going to move that P2 over by 1 more. And so 2 plus 7 equals 9. So we're going to look to see if 9 is equal to 9, which is, our target number. It is. So now we then just simply return the index values of the 2 pointers, which is 0 and 1. And we're going to return those inside of an array. So 0 and 1. And that's our answer. All right, so we're going to do the same thing as before, but we're going to just use the 2-pointer technique instead. So we're going to just do the same thing and create a function called TwoSums with an array called nums and then a target value. And first what we're going to do is we're going to set our P1 and P2 pointer at the start and at the end of the array. So P1 and then P2 equals 0 because P1 is going to be at the start, and then P2 is going to be length of nums minus 1 because it's at the end. So what we're going to do is we're going to loop as long as the P1 pointer is less than the P2 pointer. So while P1 is less than P2, and you can also do the same thing as long as it's not equal to or whatever, either one works, it'll still work. So as long as P1 is less than P2, what we're going to do is we're going to set the current sum equal to the P1 index value plus the P2 index value. So current sum, so we're going to create that variable, equals nums P1 plus nums P2, which is their actual values, not the index. And then we're going to do a conditional. So if the current sum equals the target, equals the target number, we're going to return the 2 pointers inside an array. So we're going to just go ahead and return those 2 pointers because the pointers are the actual indexes. Go ahead and return those. And then otherwise, if the target is greater than the sum, we need to now move our P1 value up because the P1 value has our smallest values. So if our target is going to be greater than the current sum, as you remember, we're going to increment our P1 value. So target value is bigger, we're going to increment the P1 value at the start. But on the other hand, if that's not the case, and the target value is less than the current sum, we're instead going to decrement that P2 value. So minus e by 1. So then after that, and we can end here, you don't have to keep going, but in the case that we wanted to handle a condition, we're going to return none if you don't find anything else. So return none. And then we're just going to go paste in these print statements. And as you remember from before, to be able to run the 2-pointer technique, you have to have a sorted array. So this only works because this is sorted. If it wasn't sorted, your 2-pointer technique is not going to work for TwoSum. So let's run the code. And as you can see, we get all the values correct. And it's in order as opposed to the other one because it's sorted. So I hope that helped you out. If it did, please subscribe to my channel for more tech interview prep. Thanks for watching. Bye.